Good morning, everyone. We're Group 1. I'm Evan Egelhard here with Mohammed, Isabella, and Shahab to bring you our final report on the Switchboard Workstation Tool Management Project. Siemens is our Capstone project sponsor. Just a little bit about Siemens here. They are a multinational company that provide a range of products and services, and the plant we worked at provided low-voltage power distribution systems. For our agenda, we'll review steps in our DMAIC process and give a reflection of our project.
So in this phase, we clearly defined the problem and developed a process map. The goal of our project was to reduce the tool-related operational expenses by 50% at the switchboard product line, with a scope that included mechanical and wiring workstations. Our problem statement addressed missing tools, using incorrect tools, excess cost, low productivity, as well as overdue calibration. Next is the process map that we developed using our Gumbo walks, observations, and data collection. It starts with an operator searching for a tool that's needed for the job, pick it up, use it, and finally return it in its place until the job is complete. Moving forward to the measuring phase, in which we collected the data, created accurate tool lists for each work area, developed a swim lane diagram, and performed an assessment for the current process. The process of collecting data here was to accurately identify the required tools at each work area. We also can see here we have two major work area categories of tools, the mechanical category and the wiring category. So before generating new accurate tool lists, we had to gather and analyze all current tool lists. Capture pictures of tools that are being used at each work area. And lastly, confirm the resulting lists with the stakeholders. The swim lane diagram here shows the cycle of a toolbox from the time it's requested for a new hire until it's used at the shop floor, replenished for missing or broken tools, and calibrated as needed. For the current process performance, we sampled one toolbox from each work area, except for the mechanical assemblies due to the high variation of the tools.
In the analyze phase, we'll review how we compared the tool list, created a category for the tools, and created a fishbone diagram. After updating the tool lists, we compared them to the current lists and found that every station except for mechanical assembly had about twice as many tools as they needed. This is due to one list being used for multiple different sections and no one being responsible for maintaining the lists. Next slide, we categorize the tools of each workstation. This helped us develop groups for the tools to be placed on the shadow board. It also showed us which workstations would be the most complex to design a board for. This was found to be the mechanical assembly workstation, which had the highest number of tools and categories. We grouped the tools into we grouped the tools like combo wrenches, pliers, and screwdrivers to make it simple to create a tool layout. Next, we created a fishbone diagram during the stage to ensure that we were addressing the root causes of our problem. The main causes were found to be no accurate tool lists, no standard tool layout for operators, and no 5S tool system emphasized in the training for technicians.
In this part, I will be talking about the actions and results from the improve phase of the project. As you can see here, several steps have been completed for this phase, which I will be summarizing some of the most important parts of these steps. First, I would like to start with how we address the problem statement initially constructed by the project team. After analysis of the project stakeholder requirements and the data collected from operators, engineers, and managers, Several alternatives were generated with customer requirements as top priority. We ensured that the selected solution addressed all aspects of the problem statement. For example, tools will have identifiable assigned locations to address issue of missing tools, and similar tools will be grouped together, and only required tools will be provided to operators. The solution will also reduce number of tools and time spent looking for tools to address excess cost and lower productivity. We also suggested marking calibrated tools with different colors on the board to identify them and assist with easier inspection of such tools. Now, we can look at some numbers and our improvements. As we mentioned earlier, our goal was to reduce tool-related operational expenses by 50%, and as you can see in the left chart, we are anticipating our solution to reduce number of tools from about 10,000 to 2,000, which is a 77% reduction, providing savings with reducing hours spent preparing tools and reducing total cost of tools in the factory. Also, as you can see on the right, our solution is expected to reduce the space consumed by tool systems from 253 to 98 square feet, providing a 61% reduction, which will provide additional space for value-added activities in the factory. Next, you can see the project team using 80-20 aluminum extrusions to build the pan wiring prototype at Siemens plant in Grand Prairie using the drawing that we developed that you can see here on the right. Here, I would like to compare our process swim lane before and after the suggested improvements. You can see in the swim lane, as mentioned earlier, that we have a set of activities for several critical roles, such as manufacturing engineers, ME techs, and calibration inspectors, before each new hire joins Siemens to prepare their toolbox. However, in the new process, all of these steps are eliminated since toolboxes will be replaced with shadow boards, and the new process will only include an ongoing visual audit of boards to ensure that they satisfy the requirements, which we'll be talking about later. And next slide, you can see the process for creating the boards using an epilogue laser at Siemens after creating our tool drawings using CorelDRAW. Finally, we would like to show you our prototype created by the project team. As you can see, we recommended moving from a one toolbox per operator system presented on the left to a shadow board per station shown on the right, which will provide better visibility and improve productivity.
Now on to the control phase, and for this phase we'll focus on our recommended change management approach along with our sustainability and learning points. To mitigate resistance to change and promote a smoother transition from toolboxes to shadow boards, we recommend following a phased approach for change management with 3 phases: initiate, plan and manage, and reinforce. And we created this timeline to visualize a phased approach, which we'll go into more detail on the next slide. The initiate phase was completed by our Capstone team with support from Siemens. This phase included a stakeholder analysis, several meetings between our team and Siemens management, and operator interviews. The deliverables for this phase are 2 physical prototypes, updated tool list, and change management recommendations. The plan and manage phase focuses on arriving at a final design through iterative prototype testing, and the deliverable for this phase will be a shadow board for each switchboard workstation manufactured by the supplier. Finally, for the reinforce phase, we recommend scheduling a shadow board kickoff meeting to introduce shadow boards and 5S audits to operators in a positive, engaging manner. And we also recommend scheduling a management reflection meeting to reflect on the successes and lessons learned from the shadow board project. For sustainability, we recommend management take the following actions. First, assign an employee to maintain the updated tool list. Having a person responsible for maintaining the tool list can ensure that the list will continue to reflect the current tool requirements at each workstation. We also recommend that management practice lean culture and proactive problem solving. Finally, we recommend building shadow boards for each work area and then replacing toolboxes at all switchboard areas on the same day or same weekend to avoid operator conflict. From this project, we learned that there's added complexity to the tool selection process from cross-trained and long-term employees. This complexity meant it took longer than expected for us to update the tool list. We also learned that custom design products in the switchboard area led to a greater variety of tools, which also meant updating the tool list took longer than expected. Finally, we learned the importance of designing shadow boards for manufacturability and flexibility. Designing for manufacturability will make it easier for the supplier to manufacture the boards within the 2-month time frame, and a flexible design can help accommodate future facility layout changes and tool list changes. Now on to our reflection. The IE courses that were especially relevant and referenced for our project were courses that discuss lean principles, manufacturing design, and decision analysis. And finally, we'd like to say thank you so much to the IMSC department for equipping us with the skills necessary to successfully complete this project and hopefully the many more projects that lie ahead in our careers as IEs. Also, thank you to Siemens for supporting us throughout this project and teaching us even more useful skills, like how to use a circular saw.